Welcome. Today we will be covering the Talen-X software application Panorama. Panorama is a tool that takes GNSS receiver data in CSV format and automatically generates over 60 engineering plots that make analyzing key receiver data metrics quick and easy. These plots give engineers and analysts the ability to view summary level, head-to-head comparison, and receiver-specific data in an intuitive graphical user interface. Panorama ensures that you spend your time looking at plots and making key decisions instead of making plots and writing reports. Panorama was designed to work seamlessly with the Talen-X products Panacea, Panacea Field Test, and RX Studio. We will be looking at Panorama through the lens of a user with at least one of these products. Let's go ahead and begin our walkthrough of the application. This is the default view when you open Panorama. The first thing that we will need to do is add a data source. This will add a file path for Panorama to look for receiver data. To add a data source, click on the green plus button in the lower left-hand corner. This will generate a file explorer where you can navigate to where your receiver data is stored. I will point to the directory where all Panacea output files are stored. This will allow me to access all of the output from Panacea, Panacea Field Test, and RX Studio. Once we've added a data source, we will see the file path listed on the left-hand side of the window. Clicking on the plus button to the left of the file path will reveal the next level down in the hierarchy. The Panacea output hierarchy is split into three sections. First are suites, which are sorted by when they were executed and break down into Panacea test plans, scenarios, and receivers. Second are fields, which are sorted by day and break down into Panacea field test scenarios and receivers. Third are RX Studio sessions, which are sorted by when they were executed and reference a single receiver. Clicking on these data sources will reveal the plots associated with them. The lower in the hierarchy you go, the further down your data source will be filtered, all the way down to a single receiver. Now let's dive into the plots themselves. They are categorized into tabs, each of which we will take a close look at. The first tab at the top of the window are summary plots. Summary plots show a very broad view of receiver data parameters. Clicking on the drop-down box that contains the name of the data metric will show a list of all available summary plots. Each plot can be sorted by receiver, scenario, test plan, and suite. This is what determines what is on the x-axis, and the y-axis is the data metric we have chosen. Let's look at the plot time of first fix from the receiver point of view. We can see each receiver listed at the bottom and a line above representing the time in seconds when that receiver got its first fix. You can add and remove receivers by clicking on their name on the left. If we sort by scenario, we can see the scenario listed on the bottom and a box representing the range of times that all included receivers got their first fix. If we remove a receiver, we can see that we have a new range of just the two remaining receivers. We can also see that the scale of the y-axis adjusted itself. Summary plots are great at looking at the performance of a group of receivers over large data sets. Next are scenario plots. These hone in on a single scenario and are mostly plotted with time on the x-axis and the parameter we care about on the y-axis. The drop-down boxes in the upper left-hand corner let you filter your data source. The drop-down box to the right of that, containing the name of the data parameter, lists all of the available plots. You can add and remove receivers the same way you can in summary plots by clicking on their name. Let's take a look at the average carrier-to-noise ratio for a scenario that included some jamming. We have three identical receivers being tested in this scenario, two that are downstream from Threat Blocker, a Talen-X anti-jam device, and one that isn't. The vertical lines on the plot are timeline events that are defined in Panacea. In this case, they represent the jamming to signal ratio in decibels. We can click and drag to zoom into a specific area of interest. As the jamming power increases, the carrier to noise ratio seen by the receivers is decreasing, but at different rates. To zoom out, either use a mouse wheel or right-click and choose Undo Zoom. Scenario plots are perfect for evaluating receiver performance head-to-head. If we want to drill down to a single receiver's performance metrics, we look to receiver plots. These are formatted similar to scenario plots in that we have our data source filtering drop-down boxes and our data metric drop-down box. Most of these plots also have time on the x-axis and the receiver parameter on the y-axis. Receiver plots give a more detailed view incorporating constellation, satellite vehicle, and frequency band specific data metrics. Let's take a look at a couple of plots for a scenario that involves a receiver tracking multiple constellations on multiple frequency bands. We'll start with the track state used plot. The legend at the top shows the different track states that a receiver can have, and these states are shown for each PRN that the receiver used during the scenario. We've used Panacea to reduce the power seen from the GLONASS constellation, as seen by our timeline events. We can see that when we reduce the power of the GLONASS constellation, these PRNs go from a code and carrier used state to acquisition and not being used. When the power returns, we can see the receiver starts tracking GLONASS PRNs again. If we hop over to the carrier to noise used heat plot, we see some timeline events indicating jamming on the L2 frequency band. The PRNs with apostrophes next to them indicate a separate frequency than L1. In this case, these are codes on the L2 band. As we can see, when the L2 band is being jammed, these PRNs have their carrier to noise ratios drop below 10. These plots are great for characterizing a single receiver's performance. Map plots are the next tab we will cover. Map plots are useful for scenarios with motion, such as those at a field test. They include a data metric drop-down box, and you can add and remove receivers by clicking on their name. The slider above the plot lets you define a specific time window that you wish to view within the scenario. You can also type a time in seconds into the boxes on the right. The scenario we are viewing is a simulation of receivers taking off of a runway. A spoofing signal is introduced during takeoff that takes the receivers a different direction once they lift off. The black line represents truth and is overlaid by importing a KML file. To import a KML file, click on the button next to the Show Hidden checkbox. Choose your KML file and click Open. If we take a look at the position error plot and move our end time slider, we can see the receivers moving down the runway. When they reach the end of the runway, they start heading in the wrong direction, and our position error rapidly increases. As we can see from the color, it reaches over 1 kilometer in roughly 10 seconds. This is just one example of how map plots can be useful to analyze dynamic scenarios. The last tab to cover is GMAP. GMAP is a Google Maps overlay that shows the overall trajectory of your receivers. It includes data source filtering drop-down boxes, and you can click on the receiver's name to add and remove them. Unlike map plots, there are no frame time sliders, so you are seeing the entire motion profile of your receivers throughout a scenario. You do, however, get a street-level view of the terrain, in which we can see the runway and surrounding area from the scenario we saw in map plots. Note that you need an internet connection to load Google Maps data. You can preload portions of the map while connected to the internet by zooming into the area of interest and clicking and dragging around the map. You will then have this area of the map available offline. This is useful if you have a known testing site and want to preload the maps on a machine prior to testing. This concludes our tutorial of Panorama. Thank you for watching. If you would like more information on Panorama or its compatible software applications, RX Studio, Panacea, and Panacea Field Test, please visit our website at www.talen-x.com or email us at info@talen-x.com.